Hey everybody, how y'all doing? We're getting ready to go through the answers for test 3, which is the unit 3 exam. I want to give the answers for that test. We want to work through each problem, and there were 20 problems altogether. So we're going to start with number 1, which was to graph x greater than -2. So we're going to graph that on the number line and then write that answer in interval notation. So we've got up here on the whiteboard, graph x greater than -2. Hold up. Yeah, x greater than -2. Forgot the negative sign. Okay, so now we're going to draw our number line. So that's our number line. And just to keep things brief and to the point, I'm just including the points, well, -2 and then 0, 2. So everything right of 0 is positive, everything to the left of 0 is negative. Since I have just the greater than sign, then at the point x equals -2, I'm going to write the parenthesis. That's my parenthesis at x equals to -2. And notice I have a parenthesis and not the square bracket. Again, parenthesis because my math symbol is just the greater than sign, which means I do not need to include -2, but I need all the x values that are greater than -2, which would be -1, 0, 1, 2, 3. In other words, everything to the right. And now I want to draw the arrow to represent all those x values that would satisfy that inequality, x greater than -2. So that's the graph. And then for interval notation, it will be this. Again, parenthesis, which means -2 was not included. And everything to the right of -2 going all the way to infinity. So that's what I was looking for number 1, this number line, and for this interval notation. Okay. For problem 2, we want to graph x is less than or equal to 20. Want to graph that and then show that in interval notation. So there's the inequality, x is less than or equal to 20. Now let's write our number line. Now, since our inequality sign is less than or equal to, then at the point x equals 20, I'm going to have my square bracket. And then I'll draw my arrow to the left. So that's the graph I was looking for. And then in interval notation, looking for this. And again, we have square bracket because we need to include the point 20. Why are we including it? Because for our symbol, we have less than or equal to. And since it has the equal to part, we need the square bracket on the number line. And then in our interval notation, we need everything less than or equal to 20. So this is going to the left all the way to negative infinity. While we have negative infinity here. And then we have the parenthesis because negative infinity, we never reach. So it's just the left parenthesis. So for problem number 2, that's the number line I was looking for and the interval notation. Okay, for problem number 3, we're going to have x minus 1/3 less than or equal to 7/12. So we have to solve that inequality for x and then graph it on a number line and then write our answer in interval notation. So there's our inequality, x minus 1/3. X minus 1/3 is less than or equal to 7/12. So to solve this, meaning to get x by itself, I'm going to need to add 1/3 to both sides. I'm adding 1/3 because I have a negative sign or subtraction sign here. So we do the opposite of subtraction, which is addition. So I'm going to add 1/3 to both sides. And now this is going to give me on the left-hand side of my less than or equal than sign, I'm going to have just x is less than or equal to 7/12 plus 1/3. Now we need to add these two fractions, but we notice that our denominators are not the same. So we need to make them the same before we can add these two fractions together. Well, I know that 3 times 4 would give me 12, and I would therefore have the same denominator. So I can multiply 1/3 by the fraction 4/4. And now what that gives me is this. Gives me x less than or equal to 7/12 plus, for this fraction, and for my numerator, I multiply 1 times 4 to give me 4. I multiply my denominators to get 3 times 4 to equal 12. And now that my denominators are the same for both fractions, I can add them together. So I end up with the inequality x is less than or equal to 11/12. And now let's draw our number line and then write this in interval notation. You'll notice that this value of 11/12 is close to the value 12/12. And since 12/12 is 12 divided by 12, which equals 1, then 11/12 is just a little less than 1. So I'm going to graph that on the number line. That circle represents where 11/12 would be on the number line. And since I have the symbol less than or equal to, I'm going to have a square bracket at 11/12. And to show all the x values less than, I'm going to draw my arrow to the left. And now to write this in interval notation. And so again, here's our answer on the number line, and this is interval notation. Again, we have the square bracket because we had the equal to part of our symbol here. And it's going to the left. What's the end? This, all the numbers in this interval, including 11/12, we're going to the left all the way to negative infinity. And so this is interval notation for this graph on the number line. Okay, moving next to, moving next to problem number 4. Problem number 4 is x minus 3/5 is greater than or equal to 7/8. Again, we're going to solve this for x and then graph our answer on a number line and then write that answer in interval notation. So we have x minus 3/5 is greater than or equal to 7/8. So to get x by itself, we're going to add 3/5 to both sides. And now we're going to simplify. On the left-hand side, I have just x. I bring down my greater than or equal to, and I bring down 7/8, and then plus 3/5. Now, I have to find a common denominator before I can add these fractions. Well, Many ways to do this. You can just add. You can multiply 8 times 5. That would give you 40. So I know that 40 would be a common denominator. So what I can do is this. I can take this denominator, that's 8, and I can multiply the fraction 3 over 5 by 8 over 8. And then for the fraction 7/8, I can multiply that by the fraction 5 over 5. I may not have shown this way in class, but as I said, there are many ways to find the common denominator. This is just another way to do it. But as long as we come up with a common denominator and then rewrite our fractions using that common denominator, we'll be able to add the fractions. So if this way doesn't make sense, you can go back to the notes from class. You can go back to previous problems where we had to add fractions that had different denominators. If you recall, we used the least common multiples, where we wrote multiples of 5, such as 5, 10, 15, 20, 25, 30, 35, 40. And then we can list multiples of 8, 8, 16, 24, 32, 40. Okay. That's another way you can see that 40 is a least common multiple or least common denominator. But now let's continue solving this. We're going to have x is greater than or equal to this first fraction. 5 times 7 equals 35. For my numerator, for my denominator, 5 times 8 equals 40. And then plus my next fraction, numerator, 3 times 8 equals 24. For my denominator, 5 times 8 equals 40. Now we have the same denominators. So now we can just add our numerators. Bring down my x greater than or equal to, and 25, 25. 35 plus 24 equals 59. And since we're adding fractions, my denominator stays the same. If I convert this to a mixed number, it's going to be, I think it's 1 and 19 over 40. Okay, so now we're going to graph this on a number line. Now, since I have this mixed number that's 1 and 19 over 40, then on a number line, this value is located somewhere between 1 and 2 because it's 1 and 19 over 40. So I'm just going to say that value, 1 and 19 over 40, is here. Don't have to be exact, but I need to make sure that I graph it so that it shows that that value is between the numbers 1 and 2. And now since this is x is greater than or equal to, I'm going to put a square bracket at that point because I have the equal to part of my symbol. And I'm drawing my arrow to the right. And now in interval notation, it will be this. Closed bracket or square bracket, 1 and 19 over 40, comma, to infinity. Those are all the x values that are greater than or equal to 1 and 19 over 40. And also let me let you know that on this test, there was a possible 38 correct answers, a total of 38 correct answers. I know there were 20 problems, but for example, in this particular problem here, there were 3 things I was looking for. Looking for x greater than 59 over 40, that's worth 1 point. The graph on the number line is worth 1 point. And then writing in interval notation, that was worth 3 points. So you can see that within one problem, you have 3 answers I'm looking for, and each of those is worth 1 point. So if you missed all 3 of these, that would be minus 3 points. Okay, next problem number 5. We have the inequality negative 7x is less than or equal to negative 70. And since this is multiplication, I know to get x by itself, I'm going to divide by negative 7. And here's a key thing. Because I'm dividing by a negative number, it's going to flip this sign from less than or equal to greater than or equal to. So now I'm going to divide both sides by negative 7. On the left-hand side, negative 7 divided by negative 7 leaves me just x is greater than or equal to, and negative 70 divided by negative 7 equals 10. So x is greater than or equal to 10. So now let's graph this on a number line. Now, since it is greater than or equal to, I'm going to have a square bracket at 10 or x equals 10, and then draw my arrow to the right to show that these are all the x values or values for x that will satisfy this inequality. And if I write this in interval notation, I'll get the following. Okay, so that's it for number 5. Moving on to number 6. where I have 24 is less than 4/3 x. So now for this problem, to get x by itself on the right-hand side, I can multiply both sides by the reciprocal of the fraction 4/3, which is 3/4. So now on the left-hand side, I have 3 times 24, which is 72. For my numerator, for my denominator, 4 times 1 equals 4. And now that's less than x, because 3/4 times 4/3 is going to equal 12 divided by 12, and 12 divided by 12 equals 1. Remember, when multiplying uh, reciprocals, you're going to always end up with 1, and that's what we want. Now, one more step, 72 divided by 4 is 18. Bring down my less than, and bring down my x. Now, if I read this from left to right, this is 18 is less than x. But if I read this from right to left, this is x is greater than 18. So let's write it that way. Because we're used to seeing our variable on the left-hand side of our math symbol. And so now let's draw this on a number line. And now since this is x is just greater than 18, then at my point x equals to 18, I'm going to have my left parenthesis. And then draw my arrow to the right. And now writing this in interval notation, we get this. So this interval notation means all the x values greater than 18 all the way to positive infinity will satisfy that inequality, x greater than 18. Okay, next problem is number 7. We have 6x is less than or equal to 2x plus 16. We have the inequality 6x is less than or equal to 2x plus 16. So to solve this for x, I'm going to begin by subtracting 2x from both sides. And now this gives me 6x minus 2x equals to 4x. I bring down my less than or equal to sign. 2x minus 2x is 0. Now I bring down my 16. Since this is 4 times x, to get x by itself, I'm going to do division because this is a multiplication problem, and we do the opposite of multiplication, which is division. On the left-hand side, 4 divided by 4 is 1. 1 times x is just x. Bring down my less than or equal to. And then on the right-hand side, I have 16 divided by 4 equals 4. So now let's graph this on a number line and then write it in interval notation. Since we have less than or equal to, I'm going to have a square bracket at 4 and draw my arrow to the left. And then in interval notation is going to be this. Okay, that's it for number 7. Moving on to number 8. So here I have the inequality 7x is less than or equal to 20x plus 26. Now to solve this for x, I'm going to subtract 7x from both sides. On the left-hand side, 7x minus 7x equals 0. Bring down my less than or equal to. 20x minus 7x equals 13x. And bring down my plus 25 plus 26. My next step is I need to subtract 26 from both sides. So on my left-hand side, I'll have negative 26. Bring down my less than or equal to, and bring down my 13x. And now we're going to divide both sides by 13. Okay, so on the left-hand side, negative 26 divided by 13 equals negative 2. Bring down less than or equal to, and then 13 divided by 13 is 1. and 1 times x equals x. Again, reading left to right, -2 is less than or equal to x, or going from right to left is x is greater than or equal to -2. So let's write it that way. Okay, so now let's write this answer in interval notation. And since it's greater than or equal to, we're going to have a square bracket at x equals to -2. And an arrow to the right to represent all the other x values that will make this inequality correct. And now we want to write this in interval notation. Okay. Okay, so that's it for number 8. Moving on to number 9. So now we have 9x plus 2 times x plus 6 is greater than 5x minus 24. Again, we want to solve this for x and then graph our answer on a number line and then write our answer in interval notation. I'll bring down my 9x. Now I have 2 times x, that gives me 2x. And now 2 times 6 to give me 12. Bring down my greater than sign, and then bring down my 5x minus 24. I see that I have 2 terms that have x, so I can combine those terms first. So 9x plus 2x gives me 11x. And then I bring down my plus 12, and then bring down greater than 5x minus 24. My next step, I want to subtract 5x from both sides. So on my left-hand side, I get 11x minus 5x equals 6x. Bring down my plus 12 is greater than negative 24. To continue to get x by itself, I need to subtract 12 from both sides. Bring down my 6x. 12 minus 12 is 0. Bring down my greater than sign. The negative 24 plus a negative 12 equals a negative 36. And now to solve for x, divide both sides by 6. My 6's cancel out on my left, leaving just x. Greater than negative 36 divided by 6 equals negative 6. So that leaves us with x is greater than negative 6. Now on a number line, this is what it looks like. Since it's just greater than, then I'm going to have my left parenthesis at the point x equals negative 6. And then draw my arrow to the right. And then for interval notation is going to be this. Okay, so that's it for number 9. Moving on to problem number 10. So we begin with the inequality 15x plus 3 times x plus 1 is greater than 2x minus 13. I bring down my negative. I bring down my 15x, and I'll multiply 3 times x to give me 3x. And then 3 times 1 to give me 3. Bring down my greater than sign and bring down the right side, which is 2x minus 13. On my left-hand side, I can combine the 15x plus the 3x, which will give me 18x. Bring down my plus 3. Bring down my greater than sign, and just bring down the right side, 2x minus 13. Now I want to subtract 2x from both sides. On my left-hand side, I have 18x minus 2x equals 16x. Bring down my plus 3. Bring down my greater than sign. 2x minus 2x is 0. And I bring down my negative 13. Next, I want to subtract 3 from both sides. On my left-hand side, that leaves me just 16x. Bring down my greater than sign, and negative 13 plus a negative 3 equals a negative 16. And now to solve for x, I divide both sides by 16. 16 divided by 16 is just 1, and 1 times x equals x. Bring down my greater than sign, and negative 16 divided by 16 gives me negative 1. So now let's graph this on a number line. And since it's just greater than, I'm going to have my parenthesis at x equals negative 1, and have my arrow going to the right. And then in interval notation, it will be this: negative 1 to infinity, parenthesis, parenthesis. Okay, so for number 11 and 12, you were given a polynomial, and you had to determine if it was a monomial, which means it had one term, a binomial, which means it had two terms, or trinomial if it had three terms. So for number 11, it had three terms, so that means it's a trinomial. For number 12, it had just one term, so that means it was a monomial. And you know what? I forgot to print out a copy of the exam. I think that's why I'm just giving the answers here, hoping that you'll go back to your email and take a look at the answers that you sent me. So I'm going to keep going. So for the next problem, number 13, you had to identify what was the degree of the polynomial. And we know that to get the degree, we had to add up the exponents for the variables of each term. And this is where I wish I had a copy of the test with me. I didn't grab it before I started recording, and doggone it, I'm so far into it now, I don't want to stop recording. I have to do it all over again. So I'll just say what the answer was. For 13, the degree was 9, and for 14, the degree was 9. But what I can tell you is that if you go back to Canvas and then you click on modules, you scroll down the page and you'll see a folder that says Mr. Lee instructional videos. I've put all my videos within that one folder. And the video that says monomials, binomials, trinomials, and how to identify the degree, you can go back and take a look at that. But I restructured how I had things in Canvas to try to make it a little more neat and easier for you to access. Okay. Okay, moving on to number 15. Now, for this one, I did write down the equation. I mean, polynomial equation. It's not an equation because we don't have an equal sign. Okay, so for number 15, we have 8y squared plus 3z squared minus 3y squared. And here we want to combine like terms. Well, I have 8y squared here, and I have minus 3y squared for that term. So now I can subtract 8y squared minus 3y squared to give me 5y squared. And then I just bring down the 3z squared. And that was for number 15. Number 16, I have 62x minus a negative 19x. So now we bring down our 62x. And now a negative times negative gives me a positive 19x. And so now I can add 62x plus 19x. That will give me 81x. As my phone goes off again. You would think I would have learned to turn this stuff down before I start recording. Okay, y'all bear with me. All right. That was 16. Moving on to number 17. Okay, so I have the polynomial p squared plus q squared minus p squared minus 10pq plus 2q squared. First, I'm going to underline everything that has a p squared as a term. That doesn't have a p squared. that has a q squared. Okay, so now p squared minus p squared is going to give me just 0. So now I want to just mark through this because I'm done with those two terms. P squared minus p squared is 0. Now I want to underline twice every term that has q squared. Right here. And now we underline that one. Okay, so 1q squared plus 2q squared leaves us 3q squared. And then I mark through it just so I know I'm done with it. And now I just bring down the term negative 10 PQ. Which could also be written as so same as negative 10 PQ plus 3Q squared. Okay, that's it for number 17. Number 18. All right, so for this one, we have a cubed minus a squared b minus a b squared minus b cubed plus a squared b plus a b squared. All right, let's underline everything that has an a cubed in the term. Okay, there's nothing else that has an a cubed, so I can't combine that with anything, so I'll just write that on my next line. And then I'll draw a line through it to let me know I'm done with it. Now I'm going to underline twice everything that has an a squared b. So now I have minus a squared b plus an a squared b. So that's going to be 0. So those two cancel out. Now I'm going to underline 3 times everything that has an a b squared. So here I have minus ab squared plus ab squared. Well, that cancel out. That equals 0. And that leaves me with just minus ab to the third power. Have nothing to combine with that, so I'm going to just bring that down. So your final answer is a cubed minus b cubed. Okay, number 19. Okay, so for this polynomial, we have u squared minus 15uv plus 26v squared plus 13u squared plus 28uv. So now I'm going to begin by underlining everything that has a u squared in the term. So I have u squared, or 1u squared, plus 13u squared equals 14u squared. Now I'm going to underline every term that has uv and underline it twice. There's one, there's the other. So now, negative 15 UV plus 18 UV will leave me 13, a positive 13 UV. Only term I have left is 26V squared, nothing to combine with that. So I'm going to just copy that down. And that's what I was looking for number 19. And for the last problem, number 20, we're given a polynomial. We're given the value for x, and we substitute that value for x in the polynomial, and then simplify. So we're going to evaluate 3x squared minus 7x plus 4. When x equals to negative 8. So what we do is, everywhere where we have an x, we're going to put in the number negative 8. So that gives me 3 times negative 8 squared minus 7 times negative 8, then plus 4. We know from PEMDAS, please excuse my dear Aunt Sally. We know we have to evaluate the exponent first before we multiply by 3. So it's 3 times, okay, -8 squared means -8 times -8, and that equals 64. Next, we have -7 times -8 gives me +56. And then I bring down my +4. And now 64 times 3, or 3 times 64, gives me 192. +56 +4. And when you add all those together, you get 252. Okay, everybody, that takes care of test number 3, unit 3 exam. I hope this helps you. If you missed anything on the exam, wow, I need some water. Okay. Take your time, go back, rework the problems, and this will be a great tool to use when we get prepared to review for our final exam. So that takes care of this video. As always, continue to keep practicing. You know I will. And I'll see you next video. Take care.